All right, so this morning we're going to pick up, and this is really pretty much going to be the end of this unit. All right, so we're going to talk about finding the area of oblique triangles today, and then we're going to go ahead and practice solving triangles using law of sines or law of cosines. All right, so um, up to this point, when we've done law of sines and law of cosines, we've just kind of done them one piece at a time, right? First, we did law of sines, where we were given any two angles and a side. All right, then we did the law of sines ambiguous case, where we had to check how many triangles we had, and that's the SSA case. And then we did law of cosines yesterday. All right, so now we need to kind of practice a little bit about, okay, when we're just giving three pieces of information and we don't know which case we're specifically working with, we need to practice, okay, what case are we dealing with? Do we use law of sines or law of cosines? If it is law of sines, do we need to deal with the ambiguous case? Do we need to check how many triangles we have? That kind of stuff. So we kind of just need to pull everything together and practice using it all at once. Okay, so the area of an oblique triangle, when you're given SAS, right? So side angle side, all right, that's basically any two sides and the angle that's between them. All right, so the area of any triangle is 1/2 the product of the length of two sides times the side of their included angle. All right, now if you want a specific formula for this, all right, that's fine. All right, we can do A is equal to, and that's area is equal to, all right, side A times side B. Whoops, I forgot my 1/2 in there. 1/2 of side A times side B times the sine of angle C. All right, and of course, if we think of a triangle, right, and we have A, B, C, then this would be side A, side B, and side C. All right, so if we're given A, B, and C, right, so A, B, and angle C, see how these are the two sides and the angle between them, all right? So it doesn't really matter which pieces we're given as long as we have two sides and the angle between them. All right, so for instance, we could also do A is equal to 1/2 um, AC times the sine of angle B. All right. So here we have, okay, well, we have side A, we have side C, and then angle B is the angle between them. All right, so that works as well. All right, and finally, we can also say, okay, well, this could be 1/2 BC times the sine of angle A. All right, so if we do that, okay, well, we have B, we have C, and we have the angle between them, which is A. All right, so all three of these will work. All right, now on your formula sheet, I don't remember which one of these is given, but you're given one of them. All right, but it's actually very easy to just kind of convert to any other one. The way that I think about it is as long as all three of your letters are different, right? Here we have A, B, C. Here we have A, B, C. Here we have A, B, C. All right, now the two out here always have to be lowercase because those always have to be sides. All right, and of course, the letter with our sign, with our trig function, always has to be uppercase because our trig functions always have angles as the arguments. All right. So like I said, one of these formulas, I don't remember which, I'm sure it's probably this one, is going to be on your formula sheet. All right, but don't think that, you can only use this, right? Like if you're only given side A, side B, and angle C, right? Like I said, you can easily convert it simply by, technically it's relabeling the triangle, but you don't really have to think about it that way. Okay, so what is the area, or what is the angle A? Uh, what is the area when angle A is 90 degrees? Okay, so of course if we have some angle A that's 90 degrees. So let's just think of this. All right. So if this is A, this is B, this is C. All right. So we're going to have the area is equal to 1/2 B times C times the sine of A, which is 90 degrees. All right. Well, from our unit circle, the sine of 90 degrees is equal to what? Does anybody remember? Ooh, speaking of which, that reminds me, you all need a unit circle quiz in the very, very near future. All right, so there will definitely be one coming up very soon for all of you. Anybody remember what sine of 90 degrees is? Slackers. All right, it's 1. All right, so in this case, this is just 1/2 B times C. All right, well, B here, all right, what is this of the triangle? What could we call this? Could we call this the base of the triangle? You guys are really into it today. And what could we call this of the triangle? Could we call that the height of the triangle? We sure could. All right. So in this case, A is equal to 1/2 the base times the height. Oh, hey, what do you know? That's the area of a right triangle, right? 1/2 base times height, or base times height over 2. All right. So basically, they're saying that this formula works for any triangle. All right. We typically only use it for oblique triangles because if we're given a right triangle, we know that that's just 1/2 base times height, right? But it actually works the same way here. Okay. Find the area of a triangular lot having two sides of lengths 90 meters and 52 meters and an included angle of 102 degrees, right? So we don't even have to label these as far as A, B, C, all of that kind of stuff, right? We know that the area is equal to 1/2 times both of the sides, all right, times the sine of the angle. All right, so all we have to do is plug that into our handy dandy calculator here. All right, so 1/2 is just 0.5 times 90 times 52 times the sine of 102 degrees. All right, we definitely want to make sure we're in degree mode here. We are. So 2,288.865 meters. And bada bing. All right, so whenever you're given two sides and the included angle, area, very easy. All right, go ahead and try this one on your own. Shouldn't take too terribly long. These are pretty straightforward. All right, so like I said, this one should go pretty quickly. So we know that the area is simply 1/2 times both of the sides times the sine of the included angle. All right, so again, we pull out our handy-dandy calculator. We say 0.5 times 24 times 18 times the sine of 80, and voila, 212.718. And this would be yards squared. Pretty straightforward. Any questions or concerns there? Yes, sir.
When do we know when it's squared and cube?
For area, it's always squared, and I forgot to do this one here, the last one. Area is always squared. Volume is always cubed. So if you're ever trying to find the volume of something, right? And the easiest way to kind of remember that is if you think of like, if you're trying to find the area of something, just think of like a square or a rectangle, right? You just do the length times the width, right? Well, assuming they're the same measurement, right? Meters, yards, inches, right? Inches times inches is inches squared, right? That's why area is squared, right? Volume, if you have a cube or some cuboid, right? Then you do length times width times height, right? So if you have meters times meters times meters, meters cubed. Right. Yep, no problem. Yeah, it really makes sense if you think about it that way. It's a lot easier than just trying to memorize what, you know. Cool beans. All right. So we can also find the area of an oblique triangle given just all three sides, right? So if we don't know any of the angles at all, that's okay, right? We can go ahead and do it using what's called Heron's formula, all right? So it says given any triangle with sides of lengths A, B, and C, the area of the triangle is given by the square root of S times S minus A times S minus B times S minus C, all right, where S is equal to A plus B plus C divided by 2. Heron sounds like some ancient Greek name. I wonder if that was a Greek mathematician who found this. This, of course, will be given to you, these two pieces here, on your formula sheet as well. All right, so find the area of a triangle having sides of length 5, 9, and 6. All right, so the first thing that we're going to want to do is find S. All right, and that is equal to the sum of your three sides divided by 2. All right, so 15 and 5 is 20, divided by 2 is 10. All right, so now the area is equal to the square root of S times S minus A times, times S minus B times S minus C. And now you really don't have to write them all in like this, right? You very easily, and this is typically what I do, as long as the numbers are nice and easy, just say, okay, well, 10 times 5 times 1 times 4. All right, so do that in our calculator here. we get the square root of 10. And 5 times 4 is 20. So 10 times 20, or 200. And we get 14.142. And they don't tell us what units this is in, so you can just say units squared. Again, pretty straightforward, especially since you'll have the formula given to you. So it's just plug and chug at this point into formulae. Okay, go ahead and try this one. It will work similarly, a little bit bigger numbers, of course. All right, so again, of course, we need to find S, which is A plus B plus C divided by 2. All right, so that's going to be 96, 168, so 84. Hopefully I did that correctly. All right, and then our area is equal to the square root of S times S minus A times S minus B times S minus C. All right, so then of course we just plug that into our handy dandy calculator. $1131.887. And of course they didn't give us units, so units squared. Good times, good times. Okay, so here we're just going to determine whether the law of sines or law of cosines is needed to solve each triangle. Okay, so first I think the easiest way to do it, all right, is to just draw some little triangle over here. All right, I do this again, somewhere over here. This is just so I don't have to worry about erasing things when I erase it. Alright, so here we will have little a. Here we will have little b. And here we will have little c. Okay, so the easiest way to do it, I would even recommend on your test, is to draw a triangle like this in pen, all right? And then, so that way it won't erase, so that you can do it kind of every time. So then whatever you're given, just circle, all right? So here I'm given angle A, I'm given angle B, and I'm given side C, all right? That is angle, side, angle, all right? And when you do it, it's not that you always want to go clockwise or you always want to go counterclockwise. You want to go to like the things closest to it, right? You don't want to be jumping 3 different pieces, all right? So in this case, you would have angle, side, angle. So this is angle, side, angle, all right? So it is important here to remind ourselves that angle, side, angle, 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 side, all right, and side, side, angle are all law of sines. All right, now be careful here. This one with the asterisks here, all right, that's the ambiguous case, right? So that's when you have to determine, that's when you have to find your H and start comparing things and say, you know, do I have none, one, or two triangles, that kind of thing. All right, and then side, angle, side, and side, 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 all right, are law of cosines. All right, so here we have angle, side, angle. That's right down here. So I know that this is law of sines. So I'll just abbreviate it LOS. All right, so now, just like I said, we can take our eraser here, erase what we just did, which again is why I recommend you do that in pen, all right? And then we say, okay, well, for 2 here, I'm given side A, I'm given side B, and I'm given angle A, all right? So this is angle, side, side, all right? Or you can think of it as side, side, angle, right? You can always flip these, right? So this could be side, angle, angle, or angle, side, side. All right, so that's this case right here, all right? So this is side, side, angle, all right? So this is a law of sines, but we have to be careful. It would be the ambiguous case, okay? So that's where we would have to check how many triangles we can have. All right, so why don't you all try to figure out what you would use on numbers 3 and 4. So these don't take too terribly long. So number 3 here, we're given A, B, and C. So that is side, side, side. So that is law of cosines. Specifically the alternate form of law of cosines, which you should have watched in the video yesterday. All right, and last but not least, all right, we are given a side B, or I'm sorry, side C, and angle B. All right, so this is side, angle, side. So side, angle, side. All right, which is law of cosines, the regular law of cosines. All right, good times. And that's it for the day. All right. Your assignment is up on Delta Math, and it only deals with the area of triangles. Right. You already had assignments over law of sines ambiguous case, law of cosines. So I felt that you should already have had ample practice in those areas. So today's assignment is just on the area of oblique triangles. It also may do area of quadrilaterals, which is fine. All you have to do is draw a diagonal, and you can use law of cosines to find the diagonal. And then you can find the area of one of the triangles, and of course, it'll just basically cut it in half. So then you can find the area of the entire quadrilateral. So does anybody have any questions or concerns before we get out of here? Yeah, tomorrow you're going to get your review sheet. Thursday we will go over the review. Like tomorrow you'll work on it. Thursday we'll go over it. Friday test. Cool. All right. Well, you guys can go ahead and hop off and get started. Have a good day.